And your focus question for today is, in how many ways can I prove triangle congruence? In how many ways can I prove triangle congruence? And the first postulate in this section is side, side, side postulate. And what the side, side, side postulate says is if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. If three sides of one are congruent to three sides of another, then the triangles are congruent. Alright, if I give you triangle ABC and I tell you that the coordinates of A are at 1, 1, point B is at 0, 3, and C is at 2, 5, and then you're given another triangle EFG and point E is at 1, negative 1, and F is at 2, negative 5, G is at 4, negative 4. And you're asked to graph both triangles. Use your graph to determine if the triangles are congruent. So since we just talked about side, side, side congruence, you're asked now to graph both of these triangles and determine if they're congruent. Alright? So, graph the triangles. You got 1, 1, 0, 3, 2, 5, the other triangle is at 1, negative 1, 2, negative 5, and 4, negative 4. What does the book tell you to do next, Julius? Not paying attention? Charles? Isaac?
It says that from the shape of the triangles, you can determine that they're not congruent.
If you're using the side-side-side formula, or the side-side-side congruence postulate, what would you have to do next to find out if these triangles are congruent? Go ahead.
Find out the measure of each side.
Find the length of each side, right? Remember earlier in the year when we were doing the distance formula to find the length of a segment? And then I showed you, what was the shortcut I showed you instead of the distance formula?
A squared plus b squared equals c squared.
And that was called, what was that called? Pythagorean theorem. Remember how much faster that was? The Pythagorean theorem that a squared plus b squared equals c squared for every right triangle. All right, watch the shortcut you can do here to determine if these triangles are congruent. All right? Take what appears to be the smallest side on each triangle. So look at the, let's turn this into a right triangle. Okay? To find this length. What's this vertical change? 2. What's the horizontal change? 1. Okay? Shortest side over here, what's the horizontal change? 2. What's the vertical change? 1. Are those two hypotenuse going to be congruent? They're both going to be congruent, right? So you know that that leg is congruent to that leg. Now, let's do the same thing with the other leg. Let's do it with this leg right here. So what is this change right here? Vertical change. 1, 2, 3, 4 units. And what's this horizontal change? 1 unit. Let's do this vertical change. What's that vertical change? Horizontal. Are those two congruent? That's going to be congruent to this. Haven't had to do any math yet, right? Just determining the size of the two triangles. Now let's look at the third leg. Vertical change. 2. Horizontal change. Vertical change. 3. Horizontal change. That's 3 and that's 3 and this one's 2 and that's 2. Are those two sides going to be congruent? No. Are the two triangles congruent? No. They are not congruent. Okay? So graphing them helps give you a better picture. You don't have to do the whole distance formula if you don't want to. But you do have to determine the other two sides of those right triangles. Clear? Everybody all right with that? Yes?
Is there a faster way to do that?
Say that again?
Is there a faster way to do that?
That's pretty dang fast. In that case, that's the fastest way to do it. If you look in the book, they did the distance formula 6 times to determine the same thing we just did without doing the distance formula at all. Okay? Yes?
If you find one that's not congruent, do you have to do the other two?
No. If we would have done the pink one first and found out that those two weren't congruent, then they're not congruent by side, 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 are they? Okay? All right, any other questions there? Yes?
How do you know which side to match up to each other?
Well, you can I just kind of eyeballed it at first. All right? But if you have to, you can just draw 3 right triangles off of each triangle and list their sides, their vertical change, and their horizontal change. And if all 3 don't match, then the triangles aren't going to be congruent. As soon as you determine one side's not congruent, then they're not congruent by side, side, side. All right, turn the page. Look at page 266. The side angle side postulate right in the middle of the page. Definition of an included angle. An angle formed by 2 adjacent sides of a polygon is called an included angle. An angle. An angle formed by two adjacent sides of a polygon is called an included angle. And on the bottom of page 266 is the side angle side postulate. And it talks about side angle side congruence. The abbreviation SAS. Side angle side postulate says that if two sides and the included angle of one triangle are congruent to two sides in the included angle of another triangle, then what do you think is true? Then the triangles are congruent. Very good. All right, and that's side angle side congruence. If two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the triangles are congruent. Here's what that would look like. One triangle. Second triangle. A side an included angle and a side of one triangle congruent to a side an included angle and another side. The triangles are congruent by side angle side. All right, do you see where the angles are in both pictures? The congruent angles are touching the congruent sides, okay? That's side included angle and a side congruent to side included angle and a side. Those two triangles are congruent. Now, if the angle is here, if the congruent angle is here, are the two triangles congruent by side angle side? Now they're not, because this angle on the right in the right triangle is not an included angle. Okay? This angle is not touching the two congruent sides. Now side angle side is true. Do you see the difference? Okay? If this is the congruent angle, can you apply side angle side? You can't, because that's not an included angle. Okay? It's got to be the included angle. Alright? Any questions on side angle side? Real important that you remember it's the included angle. Side, an included angle, and another side. Alright, take a look at page 269.